Problem number 3 has a disk spinning, brought to rest. We want to determine magnitude of total acceleration. Okay, just a note for those who may be watching this video, we changed the order of topics about a year ago, and this particular topic is now part of Module 4. It's not part of Module 2, so obviously it won't be on a current Module 2 test, current at being spring 2013, but I'll go ahead and work it anyway since it was on this practice test, and it will be useful later on. Alright, let's sketch out a drawing picture here. So we have a disk. We're given 0.05 meter radius. Okay, here's our particle spinning at 120 RPM. So that's our angular velocity, 120 revolutions per minute. We'll go ahead and convert that to radians per second. 2 pi radians in a revolution, and 60 seconds in a minute. So go ahead and get that number. 120 times 2 times pi divided by 60. It's like about 12.566 radians per second. Okay. We're told that it slows down to a stop in 0.2 seconds. Alright, so that's giving us some information about the tangential acceleration. Tangential acceleration is how fast its angular velocity will change. So let's write omega equals omega 0 plus the tangential acceleration times time. Alright, it stops. It's our final omega 0. Our initial omega is 12.566. Acceleration tangential is what we're trying to find, 0.2 seconds. So that solves our tangential acceleration as that number divided by 0.2. 62.83. Okay, let's think about units for a second. That's actually not a sub t, that's going to be alpha sub t. Okay, that's our angular tangential, our angular acceleration, which is related to the tangential acceleration. The reason I knew that is because that's radians per second up here, and then seconds right here, so radians per second squared. So AT is just the radius times alpha t. So that's going to be 0.05 times 62.83. So that's going to be 3.14159 pi. And that's going to be meters per second squared. Okay. Our normal acceleration, we have two equations for it. One of those equations is omega squared r. So we're working towards the fact that the total acceleration is equal to the tangential acceleration plus the normal acceleration. So we've got now the tangential, we're going to get the normal, and then we'll get the total from that. Omega squared, let's see, that's our 12.566 number times 0.05. Okay, this is in units of radians per second, so it's going to be radians are unitless, so it's going to be seconds squared on the bottom and meters right here, so it's going to be meters per second squared, and that number comes out to be 12.566 squared times 0.05, 7.895. So our normal acceleration is 12.895 meters per second squared. Tangential acceleration is that, and so we'll combine them over here. 7.895 squared plus that. So square that number, square that number, and take the square root of the answer. It gives us 8.49 and 7 meters per second squared. Close enough, 8.5 meters per second squared.